All right, well, let's pray and we'll get started. Father, thank you for today and for everybody who's here. Lord, help us as we think about a midterm coming up, help us to really lay hold of these things and to recognize what we know and what we don't know, and have the humility to ask questions where we need to. That we can be certain of these things, that, you just think about what the Word says, that the heavens declare the glory of our God. Father, would you be pleased to bless us with an understanding of these things for your glory and for our good. We pray this in Jesus' name. Amen. All right, I got 2 things to hand out to everybody. We used them for other purposes in my Bible class today. Okay. So your midterm basically will be the HR diagram. And you're basically going to have to know everything about it. You've got to be able to draw it. You've got to be able to label it. You've got to be able to explain it. Where things get bigger, you need to know it. Where things get redder, where things get smaller, where things get brighter, where things get heavier. You got to be able to understand it. I want you to be able to tell me every single color. I want you to be able to tell me every single size. I want you to tell me every single level of brightness, label every axis. You need to be able to give me the O, B, A, F, G, K, M, and label those things. You got to be able to label colors. You got to be able to label the main sequence. You got to be able to label white dwarfs. You got to be able to label giants, the whole thing. But if you can do all that, you'll get 100%. It's not that much, you know what I mean? We've been talking about it for at least 2 weeks now, right? In various ways. So today, we're going to make sure that by the end of the day, you understand everything. If there's anything you do not understand, shortly, you've got to ask me, okay? So we'll do it now. So your main sequence. Brand new markers, and they don't work. Main sequence. Try to do this. Let's try to do what we can without looking at notes or anything else. There's no point, right? Because we'll come back. I'm giving you the main sequence. I'm giving you everything. Okay. Let's just try to get what we can get to remember first, and that'll also help you. Okay, what do I know? What do I not know? Okay, what's on this axis? Luminosity, also known as brightness, right? Okay, good. And which way does the arrow go? Up or down? Definitely up. Luminosity is increasing as we go. Okay? There are a couple things we could say is on this axis. What are they?
Temperature.
Temperature? Good. That is the primary one. Okay? Temperature. What else could we say is on this axis?
Size.
Size, right? Especially mass. What else could we say is on this axis?
Color.
Color. Good. Okay. some degree, we could put one more label here. We could say, you know, the letter, O, B, all that kind of stuff. We're not going to worry about that right now. So there's a line here. Which way does the arrow go? Left side or right side?
Left.
Left side. You got to remember that. It's a big deal. Okay. Okay. A whole box of branding markers, and all of them are doing what this does. It's just instant. See how these do. Okay, so okay, all right. Probably the number one overwhelming feature that you should think about when you think of this is what? The
Main sequence.
main sequence. Okay. There's and basically the main sequence is essentially a line. It's not a straight line, right? Take a look at your thing here. Okay. Take a look at this. Who's got one? It's not a perfectly straight line, but you need to know basically the trend. The trend is we go from up here down here, right? Yeah. And over here, look at your line. This is more massive, right? So I need this is the kind of, you're going to have to be able to represent this. So you can either on your test, you can like draw, hey, these are the heaviest, biggest stars. You're welcome to do it that way, you know. But you can also just draw it huge, right? And then you can also, so if this is a big one, what does this need to be?
Small.
Itty bitty. Okay. And in between, you know. Okay. That's the general trend. That's the gist of it. You need to know that. You also have to be able to interpret this, by the way. So I may ask you some questions, and that's going to be fair game. And the questions are just based off the graph. If you can draw the graph, if you know the graph, you can understand the graph, then you can answer the questions. For example, stars on the left are blank in terms of brightness.
Brighter.
Brighter in terms of brightness, greater in terms of brightness, okay, whatever. Stars on the right-hand side are blank in terms of brightness. Duller, dimmer, lesser. I'd take any of that. In terms of mass, stars to the left are more or less massive. Which one?
More.
More massive. Stars to the right are
Less.
less. On the main sequence, what is the relationship between more massive stars and brightness? More massive stars are brighter, less massive stars are dimmer. None of that's hard, right? I mean, honestly, if you know this, then you know those questions. You might have to think just a little tiny bit, but that's why I'm asking them now even. So you're thinking about, I'm not trying to trick you, I'm not trying to mess with you. You don't have to have this one exact word. As long as you're relating and understanding of it, that hey, this is bigger and brighter, this is smaller and dimmer. Or, this is bigger and, what else could I say besides brighter?
Has more mass.
Hotter, good. That's more mass. Or I could say this is bigger and
Wider.
bluer. Bluer. This is smaller and
Redder.
redder. Those are how we need to be thinking about these things, okay? And if on a test, if I write a question, I'm like, I don't know where he's coming from, just kind of ask me. Because that makes sense to me, but I don't always make sense to you, and I know that. All right. Sometimes it don't even make sense to me, but hey. So, what is this line called?
Main sequence.
Main sequence. What's the overarching trend of the main sequence? You're all, okay, that's what's going on, right? Every star in the main sequence is doing fusion of what two things?
Hydrogen.
Hydrogen into helium where? In the core. Like we've hammered that, haven't we? I'd expect that too, right? What makes a main sequence star a main sequence star is fusing hydrogen into helium in its core. Stars that are not on the main sequence, stars that are going to be up here, they're fusing hydrogen into helium, just not in their core. And stars up here are doing stuff in their core, but it's not hydrogen to helium anymore. That'll come after this test. Questions right now? Yes, sir.
Are we gonna have to memorize these numbers on this?
No.
Okay.
No, man.
I didn't make sure.
No. I'm wanting big. I don't know if I've said this to you guys. Last semester when I taught it, I did. I said it quite a bit. I've tried to gear everything I'm doing in this class in such a way that in 10 years, you're going to remember certain things. If I make you remember all these numbers, that's going to be one less thing you are going to remember, and you're actually going to forget it all, right? But I hope that in 10 years, I think you will. I think that in 10 years, you'll remember, hey, if the star's bigger, it's going to be hotter, and at least, even if you don't remember blue, like it's on the other end of the electromagnetic spectrum in terms of color, right? And temperature. I think there's a pretty good chance you guys will remember that. But if I make you remember these numbers, you're not going to remember those numbers. And I think you're going to forget other things too. So I'm not, there's so much we can learn. I'm trying to just feed you stuff that I think is, when you have kids and they ask questions, I want you to be able to answer them. You know? And your kids aren't going to care about the numbers. You can always look up a number. Always. That's easy. To understand the trend, you really have to study. Okay. So that's the main sequence, right? I think if you look, go ahead and look here at this. You know, like that, certain things here just got to be in your mind, in your heart. That's the main sequence. And count on a question. What's happening with, what makes a main sequence star a main sequence star? It's fusing hydrogen into helium in the core. You got to know that. Okay. All right, we'll give you all a minute on that. Those who are writing, we'll go from there. True or false? A star can move from one spot on the main sequence to another.
False.
False. True or false? A star can move off the main sequence but stay on the HR diagram.
True.
Move off the main sequence but stay on the HR diagram.
True.
True. For instance, our sun. Where would it be on here?
Right in the middle.
Somewhere right in the middle, right? We're going to be somewhere about, let's go here. Let's call this our sun. Okay? It will not always be right here. Where will it go? First it's going to go up. Okay? As it runs out of hydrogen in its core, okay? It's you're going to have less excuse me just a second. You're going to have no more fusion pushing it out, right? That force of fusion. So it means you only have gravity. Gravity's just going to squish it down that much harder. It's going to get that much hotter. It's going to get so blazing hot that it will start fusing helium into things like carbon. We haven't talked about any of that yet, but there are other levels of fusion. And when it does that, that's going to be so hot, it's going to push it out. And it's going to go from a little medium-sized main sequence star to a red giant. Up here, right? Red giant. I don't need you to tell me that this is a red giant. You just need to know these are giants. You know what'll tell me that it's red?
Where you put it?
Where I put it, right? Okay, so red giants are furthest to the right. What makes it red?
Temperature.
Temperature. It's cool. Okay. The outer layers are going to be cool. So our star will go here until it fuses all of that it can, until basically all the core is carbon. And then our star is not big enough that after that, it can do anything else. And so after that point, and this is a little ahead of the game, but this is what happens. After that, for our star, when it runs out of helium and all that's left is this carbon core, whatever's left is just going to float off into space. Okay, the outer layers. But the core, what's the core going to be made of?
Carbon.
Carbon. By the way, fun fact, super compressed carbon solid, what is that?
Diamonds.
Diamonds. So you literally have a diamond core. Now the outside layers were cool, which is why the star was red. And the outside layers were huge, which is why this is way up here on the luminosity. But when that's all done, all that's left is this core that's wicked hot, but small and dim. So wicked hot, small and dim, it needs to be somewhere over here, but it's dim, so it's got to be somewhere down here. So what are these?
White
White
dwarfs.
White dwarfs. So you'll need to know that. So my giants are up here. My white dwarfs are down here. They're amazingly hot. They're not doing any more fusion. They will just slowly cool down and fade. Eventually they'll become what's called a black dwarf. They're not doing any fusion. They'll just be black and cold, like a piece of coal. They'll still be diamond, but anyway. Do you know how excited my 7-year-old got when I told him that white dwarfs are made of diamonds?
Gotta go steal the sun, the dead sun now.
Hmm?
I go steal the dead sun.
Yeah. He didn't understand why he couldn't just touch it. It's hot. All right, so let's come back to here's our sun. It's on the main sequence. Can it change spots on the main sequence? No. Can it change spots on the graph? Yes. First thing is it'll go up here to the giant phase. And then for our sun, it'll go down to the white dwarf. If you have a really massive star, like one of these that's up here, and then it goes giant, it does not ever go white dwarf. Well, take that back. For like a second, it goes white dwarf. But it'll quickly go neutron star, and if it's big enough, it'll go, it'll go white dwarf. Then past white dwarf, it'll go into supernova, and then after the supernova, it'll either go into neutron star, which we don't have up here, by the way, or black hole, which also we don't have up here. Okay? So main sequence, we do not change spots in the main sequence. The main sequence is only one part of the Hertzsprung-Russell diagram, which is graphing luminosity versus temperature, and so star can change spots after it leaves the main sequence. First, it's going to go to the giant. And depending on where it's at on the giant scale, how massive it is, it may go white dwarf, or it may leave this entirely in a supernova. Okay? All right. Any questions right now? Everybody feels good? You feel like you can draw this? Are you just going to wait till Tuesday and find out if you can draw this?
Yeah,
Don't do that. Yeah, don't do that. Guys, I've given you the test, right? So your mission is to do this. Like, not once. Don't show up next Tuesday for the first time and try this. Do it. Do it a bunch. Make sure that you can represent this. No, you don't need the numbers, right? But you got to be able to label. And we'll put the other labels up here in just a minute. Yes, sir.
Shouldn't the size be on that axis, on the vertical one? Because
Well,
there's big giants over there. We say
Yeah,
the size will
so-
go away.
yeah, but I get giants up here, right?
Yeah, that doesn't make sense if we say the size goes up that way.
The mass.
The mass, yeah, but then you put size there.
Well, somebody said size. I'm like, I'll work with that. But I really mean mass.
I was just
Let's
confused
erase
by that.
size.
Yeah.
Let's erase size. Because you're thinking like volume, right?
Yes.
Yeah.
No.
Hear that. Okay. That's a good question, or a good point. Very valid. Okay. I was being too accommodating. Okay. Other things we need to know about this, right? You need to know blue, right? What's next?
White,
White,
yellow, orange.
Yellow,
yellow,
orange,
orange,
red.
red, right? Blue, white, yellow, orange, red. Good. You need to know where our sun is,
Amazing.
right? Well, but also like in relation to color and all that kind of, because you're going to label all this, right? The other thing is below blue down here. What letter? O. I'm going to put it here. O. What is our sun?
G.
G. Okay. O, B, A, F, G,
K.
K,
M.
N. O, B, A, fine girl, kiss me. You got that? You got this, right? So you have to be able to label this, you have to be able to label color, the trend in terms of mass, the trend in terms of luminosity, identify where the giants are, the main sequence, the white dwarfs. If I were to ask you a specific question, I don't know that I will, but if I were to say, hey, why are white dwarfs so far left on the x-axis, but they're so low on the y-axis? What would you tell me?
Small.
They're very hot,
Dim.
but they're very dim, right? They're not, and you know, and frankly, the reason they're so dim is they're not doing fusion, right? Any light is literally just, it's like when you have a piece of metal and you heat it up, flaming hot, you take it out of the flame, right? And it's still glowing for a while. That's all they're doing. They're just glowing as they give off the last of their heat over a very long period of time. Conversely, why is a red giant so high up on the y-axis, but so far right on the x-axis?
Luminosity.
Oh yes, it's very luminous. What makes it so luminous?
It's a large
More-
size.
Large surface area, right?
So you-
Just a lot more area for the light to come through. It's good. I don't know that I'm going to ask you that, but I might. It'd be fair game. Okay. So show the HR diagram. Draw the HR diagram. Show all stars, types of stars in their proper location. This is the kind of thing I'm looking for, okay? Label all star types. So white dwarfs, main sequence, giants. Good. Label the major line of stars formed on the graph. Label stellar classifications, that's these. O, B, A, fine girl, kiss me. And if you don't know that, would you just write that down on here? That's what that is, label stellar classifications, O, B, A, fine girl, kiss me. You need to know that, right? That's all those are. Okay, label colors. If I were to ask you what color is an O class, you should tell me blue. What color is a G class, you should tell me yellow. What color is an M class, you should tell me red. Those would be fair, wouldn't they? I wouldn't ask you a bunch of intermediate stuff. I wouldn't make you go, oh, is a B or an A, or those wouldn't. I wouldn't make you do that. But you need to know the ends, and you need to know our sun. Okay? All right. Represent or label stellar mass. So tell me bigger, smaller, right? Either tell me that or simply draw them bigger or smaller. Okay. Represent temperature. Label your axes. Luminosity. Draw arrows to show the direction of the axes. That's it. If it's not on here for what I want on the graph, it doesn't need to be on here. I'm not going to nitpick anything that's not on here. Okay. I want to talk about the nature of light just a little bit, okay? It's in connection to all this. Why is a blue star blue?
Frequency of, no?
Frequency of light, okay? Blue is higher or lower energy relative to all these others.
Higher.
Hi.
Higher frequency, right? Higher energy, good. Okay, which means, is it coming from a cooler or a hotter source? Hotter, it's coming from a hotter source, okay? So these bluer stars are bluer because they're hotter. Hydrogen. They've got a ton of hydrogen out in their outer layers, okay? And that matters. So hydrogen fusing into helium, right? Hydrogen, when it gets heated up, as a gas anyways, right? And we've drawn this before, we've talked about this before, but as it gets heated up, this electron goes out to a higher energy level where it's not stable. It wants to fall back down, right? And so to fall back down, it has to emit a photon of light. Depending on which energy level it's falling to and falling from, it emits energy at different wavelengths of light. The further it falls, the more energy it gave off. The more energy it gave off, the bluer the wavelength of light is going to be. The less energy it falls, the redder it's going to be, because its fall in energy level correlates to its wavelength of light. Remember that we had long wavelengths, right, and down to short wavelengths, right? So a big jump, say from a third or fourth orbital down to the first, that's a huge jump down, a lot of energy lost. That's going to put us somewhere down here, toward the blue or the violet range, okay? Super high energy. If I only fell from 2 to 1, that's not a big jump. That's going to be light released somewhere on this energy, okay? It can only release light at the term that's used is discrete, or we might say specific wavelengths of light. Hydrogen is not able just to produce any old wavelength of light. It can only produce certain wavelengths of light, okay? It's called light emission spectra. So here's the deal. If you took a closed container of hydrogen gas in a tube and you excited it with electricity, it's going to glow. It's going to produce light because these electrons will literally be doing this, okay? When we look at it with our eyes, it's going to have a very specific color, right? If I put that light through a prism, that prism is going to break it apart into the different wavelengths, and you'll be able to see the difference. You're not going to see a full rainbow. I take a prism and I take white light from the sun, you see the full rainbow, you see all the colors. You don't see that when you're just dealing with hydrogen. You see very specific wavelengths of light. Let me show you this.